Hello everyone. Today we are going to learn 4.3 elementary mechanics. Okay, so also this section I'm gonna do only one questions, one problem here because very similar other problems in this section. Okay, so Newton's second law of motion. So we have F equal to ma as a formula, Newton's second law, right? So F stands for force and m stands for mass, right? And a from the acceleration, right? So F equal to ma, so force equal to mass times acceleration. Okay, now we have gravity. Yeah. So we call G. So magnitude of force is mg. And then we have G is the called acceleration due to gravity. Yeah. Okay, so normally G equal to 9.8 meter per second square because it's acceleration, right? So unit, right? So we called this unit the International System Unit. So we called SI unit. And then if we indicate 9.8 meter per second, we change it to the centimeter, then that's 980 centimeter, right? And if we are using feet per second square, then 32 feet. And we call this as a British unit. All right. Okay, now, so we had the force equal to ma. We can express this one as the mass and then acceleration, which is the same as the derivative of velocity, right? We knew that from calculus 1. And then I think we did that before too, right? Yeah. So the note. All right. Then let me do this one. Uh, we can also mv prime equal to negative mg. So mg is the force due to gravity, right? And then we have a negative sign here. So negative sign, we the object, the gravity pulls object downward. That's why we have a negative, yeah? And plus, we add another force, which is air, I'm not air resistance. That's the example. So F sub 1 is the resisting force. Okay, so for example, so like air resistant. Make sense? Okay, now let us do one question. So we have a constant horizontal force of 27 N. So what is N? N is a unit we called Newton. Yeah. Then this will be 1 kilogram times meter per second square, right? Then we can notice that the unit, look, that's M kilogram, right? And then A, which is acceleration, meter per second square by SI unit, right? Remember? Okay. So the that is unit of force, which is Newton. Clear? Okay, so we have a 27 M pushes a 35 kilogram mass through a medium that resists. Okay, so we just learned last section, medium, right? That resists. In that case, resist is a medium, right? Okay, if motion with 0.9 Newton, so that's the resisting force. So your book indicate that F sub 1, right? F sub 1, not the F sub R, F sub 1. For every meter per second of speed, the initial velocity of a mass is 6 meter per second in the direction opposite. So since opposite, we are using negative to the direction of applied force. So we want to find velocity of mass after 30 seconds. So what's the goal, right? So the goal is we want to find the equation. So in that case, we need to find the solution, right? So v of t and what's the velocity, right? When t equal to 30, right? Find v of t when t equal to 30 seconds. That is the goal, right? Then, like earlier section, right? So we found the general solution. Then we found the C, which is particular solution, right? By given initial value, right? Then when t equal to 30, just find velocity. Yeah? Okay. So I brought the formulas here, right? So mv prime minus mg plus f sub 1, right? Okay, so what's the mass in the case? It's a straightforward, right? 35 kilogram mass, yeah? So that is a 35 kilogram. Okay, now v prime I want to express as dv over dt. dv over dt equal to what is mg, right? So mg will be uh, a constant horizontal force. So that will be mg, but then look, this is a horizontal, right? So it's a positive horizontal, not the downward, right? So we are using positive. So 27 and uh, the resistant, right? So we have a 0.9. So look, they say that resist in motion with zero point 0.9 Newton for every meter per second of speed, right? So meter per second of speed means velocity, right? Velocity. Okay, so we express this one since resistant. So we're using negative 0.9 and velocity. Make sense? Okay, now let's make dvdt one side. All right, so there will be divided by 35 every term, right? So there will be dv over dt equal to 27 times 35, which is just leave? Okay, just leave. Okay, let's just leave because we don't want to carry the decimal. Yeah. Okay, so 27 over 35. How about 0.9 over 35? We have to, right? So we have to calculate. So there will be 0.0257 V. Okay, so let me arrange. Yeah, so since we have a V there, so let's move to the other side. So there will be 0257V. Let me just do one step, right? Yeah. So we will have dv over dt plus 0.0257V equal to 27 over 35, right? Okay. Can you recognize this is a form of, we can use the integrating factor, right? So let me write down form of y prime plus polynomial of x equal to f of x, right? So there will be y prime plus polynomial y and the f of x, the function, right? Then what we are using, integrating factor, right? So note integrating factor. So mu of t equal to e to the whatever polynomial, right? dt. So there will be, in that case, this is a polynomial, right? So point zero, oops, not like that. 0.0257 dt. Okay, so we integrate the number, then we get e to the 0.0257t. Yeah. Okay. All right. So then we multiply this one for every term, right? So we had the experience. So let me do, so dv over dt plus 0.0257v equal to 27 over 35, right? So we multiply by e to the 0.0257t. Okay, so what do you get? So we have first term e to the 0.0257t dv over dt plus 0.0257 e to the 0.0257v equal to 27 over 35 e to the 0.0257t. Yeah? Okay. Now, we can check the, right? So we can check the, what is called? The derivative, right? So check, we always do that, right? So check the product rule, right? Remember? Yeah, product rule. So we have d over dt of e to the 0.0257t and v in that case, right? Okay, so that would be f g f prime g plus f g prime, right? So f prime, so e to the that function and chain rule, right? So we will get 0.0257 e to the 0.0257 t v, which is v, and plus f e to the 0.0257t and g prime dv over dt, right? So let's check that. Do we get, this is the first term, this is the second term, yeah? It is correct, right? So yes, right? Okay, then we can use that. Uh, the left side equal to right side. Yeah. All right. So there will be equal to right side 27 over 35 e to the point 02570. Yeah? Make sense? Or should I write down clearly? Okay. So right side. This is the right hand side. And this is the left hand side. Copy. So all together, right? Left hand side equal to right hand side. Yeah. Okay, now we want to solve for B, right? Solve for B. How? Yeah, integral. Yeah. So we integral both sides. So we have d over dt e to the point 0 to 570 v equal to 27 over 35 e to the point 0 to 570. Okay, now left side we get e to the point 0 to 570 v, right? Okay, how about right side? So 27 over 35 e to the point 0 to 570. And then integral also divided by new power, right? So point 0 to 57, right? Did I make a mistake? Yeah. Okay, plus C. Yeah, plus C. Okay, now I need uh, more, yeah, pages. Okay, so sorry for C, right? I'm sorry, sorry for B. But then let's calculate this one. Let's calculate this number. So divide by 0.0257. Yeah. So if we calculate, this will be 30.01668. So e to the point 02570 v equal to e to the point 02570 plus c. Okay, now v is there, so we divide by e to the point 02570. So v will be 30.01668 e to the point 02570. Okay, divide by every term, right? So e to the point 02570, e to the point 02570, right? Okay, now we can simplify first term. Yeah. So we can simplify. And second term, we can use a negative power, right? So we had the experience before. So V over T equal to 30.01668 plus e to the negative point 02570 C, right? Yeah. Okay, now almost done. So this is a general solution, right? So general solution. And then we want to find the particular solution by using initial value, right? So initial value, we have initial velocity of mass is 6 meters per second, right? But then they say that in the direction of opposite to the direction of applied force. So we are going to express this one will be v of 0 equal to -6. So to find, okay, use v of 0 equal to -6. Yeah, opposite direction. Yeah, means opposite direction. Okay, so this means t equal to 0, right? So we have a v of t. Let me just copy. V of t. Copy. So v of 0, right? So v of 0 equal to -6 equal to 30.01668 plus e to the negative 0.0257 0. See? Yeah. Okay, e to the 0 power is 1. So we have, what do you get? -6 equal to 30.01668 plus c. So can you please calculate what's the c for? Yeah. C equal to -36.01668. Okay, now v of t, which is 30.01668 plus e to the negative 0.0257. Tc was -36. So I want to put the constant in front. So that is constant, right? For second term. Okay. Negative, yeah. All right. But then we want to know about the velocity when t equal to 30 seconds, right? Okay, let's find out, then we're done, right? So find the velocity. When t equal to 30, right? So we're using v of 30 equal to 30.01668 -36.01668 e to the negative point 0.257t, which is 30, right? Can you please calculate? Okay, so I have, that is a 13.36. Velocity, we had a unit earlier, meter per second, right? So meter per second. Okay? All right. Thank you for watching. Bye.